My name is Rose Hu, and currently I'm an associate professor with the Electrical and Computer Engineering Department of Utah State University. And since I joined Utah State University, I have conducted research mainly in the areas of next generation communications network design, optimization, and performance evaluation. We really want to design the next generation communications network so that the communications can be carried smoothly, effectively, efficiently, and with required performance demand. So in order to achieve that, we are doing research on different areas and different technologies. So those technologies mainly include cross-layer optimization, radio resource management, green radio, multimedia communication, and also wireless system modeling and simulation.
One of my current projects is mobile association in heterogeneous networks. Mobile association in heterogeneous network plays an important role to exploit the capacity gap. On the other hand, a future wireless network will support multimedia applications with various quality service requirements.
Traditionally, cellular network, we call that homogeneous. So homogeneous is versus heterogeneous. So homogeneous meaning in the traditional homogeneous cellular network, all the base stations pretty much the same size, same power level, same coverage range. But now we create a heterogeneous network. So we mixed high power transmission base stations and low power transmission base stations, such as you're probably familiar with femto nodes and pico nodes. So those very small transmission power nodes, they mainly actually offload the traffic from the cellular network so that you can get more capacity from these low power transmission nodes. And also sometimes they offload traffic, and sometimes they mainly actually try to cover a data zone. So in certain area, just like your base station, power just cannot penetrate through that, shadow area or some like tunneling area. So you put a low power node there to cover that coverage hole.
So my research focused on the heterogeneous network. This is a novel network architecture, so which can narrow the gap between the capacity and the demand. And also the heterogeneous networks, it can extend the wireless coverage, and also it can support more users. Besides, it can improve the cell edge user performance so that our users, they can have better service qualities.
Currently, I'm working on two main research projects. First one is device-to-device communication underlying the cellular networks. Device-to-device communication, or we call it D2D communication, means a user device can communicate with another nearby user device directly with the reuse of the cellular network resources, but without the help of the base station. That's what we call the D2D communication. The D2D communication has attracted a lot of research attention because they can increase the cellular capacity, the user throughput, and also extending the battery life of the user device.
How to design such a network, but with minimal energy consumption. I would say that actually is another major impact people can see very obviously, because we're talking about green these days. We really want to see, design such a network in order to meet all those demands, but at the same time, keep your energy consumption flat. We need really good communication. So it's not just, I send the bits bytes through the channel and you receive the bits bytes, but it doesn't matter how many bits get lost. It doesn't matter how much delay it takes. So those actually is really what we are concerned as a researcher. We really want to design a good communication technology that can deliver your communication bits bytes very, very good quality.